Now we will learn some examples where we have to compare the acyclic structure with the RS method. By the RS method we can compare the acyclic structure, that two structure is given with the structural relations we have to find. Then they are identical, they are enantiomer, they are diastereomer, which type of structure is there. By the RS method we can get to know about the detail of knowledge about the structure. Suppose this structure is given, there is a general format A, B, C, D, E, F. I have written A, B, C, D format because in exam in questions maybe some group will be present in the A position, B position, C, D, E positions. A, B, C, D all are different. That doesn't mean that two groups will be always different. There may be two groups, three groups may be same. So only I want to denote A, B, C, D means any group will be present. Then you have to find the RS about the chiral center. We have to find RS only about the chiral center. This is a chiral center, this is a chiral center. When all the four different groups are attached, when there will be no any four different group attached, means two groups will be identical, three groups will be identical, then that center will not be chiral. In such type of cases we didn't need to find about we have not necessary to there is no necessary to find the RS of that center. Only chiral carbon need to find RS. Then there are two chiral center. This compound also have a two chiral centers. This in this. And what is the relations between these two compounds? Suppose this compound, the configuration maybe three cases are there. First case is this is R and R. If this will be R configuration, this will be R configuration, and this will also will have R configuration. This will be R configuration. If both R and R, this type of configuration will be there, then the groups will be identical. This will be identical if R and R configuration will be identical. If the second case, if R and R, this chiral center will be R configuration, this chiral center will be R configurations. But this chiral center S and S, these two chiral center will have S and S configuration. Such type of arrangement where R and R, left side R and right side S and S. The opposite is there, R converted to S, R converted to S. Whole configuration will converted to opposite. If 3 R will be there, R and R, S, S, S. This is also the same case. I want to show that if the configuration will be opposite, is completely opposite configuration will be there in the second compounds, such as this will be R, this is S, this is R, this is S. Then these two compounds are enantiomer to each other. Now the case of diastereomer. This is a R, this is an R, but this is a R, this is an S. One configuration is opposite. This is R, this is an S. Here is R and R, but second R and S. One configuration is changes. R, one R is same. R changes to S. One configuration is changes. If more than one chiral center is there, 2 chiral center, 3, 4, 5, 6 chiral center is there. If any one chiral center will be different, then that will be diastereomer. If there is, suppose these compounds will have 3 chiral centers. Suppose this compound have a 3 chiral center. First will be R, second will be R. The second compounds R and S. Any one is different, that means these two are diastereomer. It may be if maybe R, S, S. This is also diastereomer. Two are different, this is also diastereomer. But if all the configuration will be different, if this is R and R, if this will be S, 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 in that case that will be enantiomer, not diastereomer. This is the case of diastereomer, means if 5 chiral center is there, one is R, any R, S, R, S, S. Maybe this is left side, and right side should be for diastereomer. At least one must be different. If all be different, if there is 5, if 5 will be opposite, if S, S, R, R, S, R, S, S, R. If this is completely opposite, this is approximately look like a mirror image, then they will be enantiomer. But if anyone will be different, this is a R, means R and R all are different, but this R, this is R same. In this case, this will be diastereomer. So anyone will be different, then that will be diastereomer. Now we learn the examples. The same will be there. If R will be there, this is identical. First case, this is the first case. Now second case, if will be completely opposite configurations, R and S, R, S, such left side R, yeah, anything, maybe left side R and S, and right side S and R. This is opposite, this is opposite. This is also enantiomer. So enantiomer, diastereomer, identical, clear. These three are the relations generally asked in the examinations. Now we'll learn about the questions. This is a source projection formula, this is a wedge projection formula. Now we have to find the relations between these two compounds. Now we have to write this is a feature projection formula. Now also we have to need to write this features projection formula. We can also do a from the wedge projection formula, we can also do the same things. We can also write Newman projection formula, and we have to find the relations. Anyway, we can find the relations between these two compound. First of all, we have to find the chiral center. This is a chiral center because this is a star. Chiral center is denoted by star. There is a 4 different groups are attached, 1, 2, 3, and 1 is 4. But this is not chiral center because 2 groups are identical. So this is not chiral center. This is a chiral center. Similarly, this is a chiral center. 4 different groups are attached, but this is not chiral center. So we have to compare. So we need to compare these two chiral center only. If it will be R, then identical. If it will be R and it will be S, then this will be enantiomer. Diastereomer, there is only chance of diastereomer because for being a diastereomer, there must be a 2 or 3 or 4, means more than one chiral center should be present in a compound. But there is different chiral centers. But for one chiral center, only enantiomer or identical will be possible if the molecular formula is same. These two are the have same molecular formula, C5H12O. Molecular formula is same, these two compounds, so definitely they will be a isomers. Which type of isomers identical, which type of there, so you have to find the RS configuration about this chiral center. Now we have to find the chiral center about this center. Now for RS configuration, H group should be in the dash position. So to view from the left side, if you will view from this right side, if you view from this side, then this will be in the wedge position. This H will be in the wedge positions. Now this wedge positions means after getting answer, we have to revert the answer, we have to opposite the answer. If this is a wedge position, then the numbering is done, 1, 2, 3, 4. Numbering is priority is done. Now we have to rotate the groups by ignoring the, we have to draw a arrow ignoring the fourth group. Now this is the arrow. Now this is a right, this is a clockwise, so R configuration will be there, but fourth priority group not in the dash position, this is in the wedge position, so the answer will be S. Here S is shown. Now for this, the OH group already occupy a wedge position, so the H will be definitely in the dash position. So H is in fourth priority group in the dash position. This is a fine. So whatever the answer will be, that will be our final answer. So numbering is done, priority is done, 1, 2, 3, 4. Now we have to ignore H and we have to draw arrow 1, 2, 3. This is a R. So R will be our final. This is S. This is an R. It means they are enantiomer to each other. If this will be R and this will be R, then they are identical. But this is a S. This is a R. They are opposite of in configuration, so this will be enantiomer to each other. Now second example, this is a Fisher's projection is shown, this is a wedge is shown. So we have to find the relations between this. So we have to find first of all chiral center. This is a chiral center. This is a chiral center. Two chiral center. Here is also chiral center. Here is also chiral center. Two chiral center. So there is a possibility of identical enantiomer or diastereomer because there is a more than one chiral center is there. So there is a possibility to show a diastereomer. So we have to find the RS configuration, and then we have to check what possible answer is this. So we have to find this is a RS configuration, this is a S configuration, this is a S configuration. These two are the S configurations, and this also have a R configuration. This chiral center S configuration means this is a S, this is an S, this is a R, this is a S. Means one is opposite, a second is same. Means they are diastereomer. Similarly, this is a Newman projection formula is shown. Now the Newman projection formula, we have to convert this Newman projection formula into a wedge projection formula. Then simply we need to put this, take this carbon and put this positions. This is a now CH3 in the right side, CH2, CH3. This is in the left side, H in upper side. Upper side means it is in downward side. Actually, upper side means this is in a downward side. Now I will make some arrangement. Now this is downward side. Now this is back carbon. The carbon chlorine in the right side and CH3 in the left side. But this is in an anti-conformation. Anti-conformation means Cl will be in the left side, CH3 will be in the right side. This CH3 in the right side, L in the left side. If it will be eclipse, then the Cl will be right side. If it will be eclipse, but here is just a stagger in anti form, so this is an opposite. How I will, this is writing from Newman to feature position, I will make you very much clear in the separate topic where Newman position is changes to feature position, how they are changes. Now this is a basis position formula. After basis formula we can easily find RS configuration. This is a 2 chiral centers, here is also 2 chiral center. Now this is a priority is given, this configuration is S, this configuration is S configuration we are getting, and this is also getting, there is a waste position also, CH3 already shown, chlorine is a waste position, so definitely H will be in the dash position, so H is in dash position, H is in dash positions, and we have to find the configuration. This is S, this is in S. Now this is in S, this is in S, so S are identical, this is in a identical, so these two are identical. Similarly we have to find, this is a Newman position formula is shown, is Sauer's position formula is shown, we have to find the RS configurations. This is Newman position formula, this is an anti-confirmation, that's why chlorine will be in the right, H will be in the left, this CH3 will be in the downward side, but this bromine will be in the right, this is anti-confirmation, so right will be in the left and left will be in the right, so bromine will be in the left, CH3 will be in the right. Now this is in a H is downward side, so it will be in upper side. Now we have to find the configuration about these two, so this is a R, this is an R configuration, R and R configuration. I have to see from the left side, right side, means we have to see view from the right side, so it is a Sauer's position formula. If we will see in the right side, then H will definitely come in the dash positions, this will in the in dash positions, this will be in the CH3 in the waste position. So H is already in the fourth priority group in the dash position, so we did not need to bother about the configurations. So if you see from the right side, then you have to see also from this right side, but in here examinations we have seen this is from H in a dash positions. Now we have to find the priority, 1 priority, 2 priority, 3 priority. This is in a clockwise, the R will be our answer from the left side. If you will see from the right side, then H will be in the front positions, so in that case there is something changes, so R will our configurations, and here is also H in the vertical position, so answer will be different. This is in a S changes to R because fourth priority group is the not in the dash position, so R and R there, so that will be identical. Now the similar examinations, Newman position changes to feature projection formula. This CH3, this is an eclipse confirmation, so CH3 and OH, CH3 will be in the right side, OH will be in the left side. Now this COH will be in the upper side, this is in the upper side, and here OH will be in the right side and H will be in the left side because they are eclipse, so we did not need to further. Now we have to find this is S, this is an S, this configuration is R, this configuration is R, so S. Now this is a R and R, so opposite there will be enantiomer. Here is shown S and S and R configuration completely changes, so that will be enantiomer. Similar thing happened in this examinations. We have to find the RS configurations. I have shown this is R, this is S configuration, this is R configuration. Configuration completely changes, that means they are showing enantiomer. Here we have to also find the chiral center, we have to find the RS configurations. There is only one chiral center is there, the two H group are similar, so we have to check only about this group. This is R, this is R, means they are identical. R and R, they are identical. It is only shown the how the rotations are possible. This is not much important. We have to find the RS configurations in a feature projection formula. This is a feature projection formula. We have to assign the priority 1, 2, 3, 4. Fourth priority group not in the lowest position, so the answer will be different. Now this fourth priority group is in the dash positions. Fourth priority group, this is a dash positions. This is a wedge positions. This is a wedge positions of H is in the dash position. H is in dash position is away from the viewer, so it is a fine. So we have to assign the priority 1 priority, 2 priority, 3 priority, 4 priority. So fourth priority group in the dash position, this is a fine. So whatever the answer, that will be our final. So 1, 2, 3. So to do clockwise, the answer will be R. Here also answer is shown in the R. Here also it I have shown this is a wedge position, this is a dash position. Wedge in the Fisher's projection formula, whatever the vertical lines it represent dash and horizontal line represent wedge. So we have to find wastage position formula to a features position formula. How the wastage position formula changes to features position formula? Now I will make understand.